All right. Hey, everybody. Thanks so much for joining this talk all about demystifying cannabis testing and cannabis testing labs. So, my goal for this talk is to essentially empower you with the information that you need so that you can tell whether a lab is producing fraudulent results or not, and how to suss out the bad labs and find the good labs. That's ultimately the goal here. And let's just go ahead and move forward here. If you don't know who I am, I'm Jason Wilson. I'm a scientist that's been working in the cannabis space for pretty much a decade or so now. I'm the owner and producer of the Curious About Cannabis brand, which is a science education initiative by Natural Learning Enterprises that is just all focused on trying to help people avoid some of the hype and hyperbole around cannabis science and to understand what's real and what's not. So I've been studying the cannabis plant in labs, like I said, for about a decade or so, both studying the biology of the cannabis plant, but also the chemistry of the cannabis plant, the microbiology of the cannabis plant. And I've learned a few things here or there. There's still a ton I don't know, and I'll be pretty upfront about that. And if there's anyone out there that says they know it all about cannabis and cannabis science, then they're lying to you or to themselves. But I've picked up a few things, and I'm hoping that I can share my experience and hopefully that'll be valuable to somebody out there. Um, I'm the author of the Curious About Cannabis book. If you're not familiar with that book, I invite you to check it out. It provides a wide survey of cannabis science topics from botany, chemistry, extraction science and technology, testing, how cannabis affects the body, all sorts of stuff like that. And I'm also the host of the Curious About Cannabis podcast, which I encourage you to check out, where I am able to connect with other folks that are in the cannabis space. Usually it's other researchers and clinicians and that sort of thing, but also, you know, patients and artists and all sorts of people that are connected to the cannabis plant. And we basically just try to have critical discussions about cannabis. Sometimes it's about cannabis science, sometimes it's a little more loose, but we just try to highlight unique perspectives and insights that we can. So, with that, I wanted to point out my relevant experience to this talk today. So, I've been involved in cannabis testing for quite a while. My first foray into cannabis testing was with helping to build a lab called Cannabis Research in Southern Oregon. We were one of the first three accredited labs in Oregon that was testing cannabis. All three of us were accredited in the same week. So none of us can claim that we were the first, but Cannabis Research was one of those first three that were accredited in Oregon. And this was at a time when cannabis testing was only just becoming to be a thing on regulators' radar. In cannabis industries broadly. At that time, Colorado didn't really have much cannabis testing. Washington didn't have much cannabis testing. Um, and so Oregon was starting to kind of take that seriously. And we'd been operating before Oregon even brought on its cannabis testing rules, looking forward and knowing that eventually, as a natural product, as a commodity, testing is going to be something that's going to be required at some point. And at that lab, we had a reputation for quote unquote low THC numbers, which once all labs started to get accredited and data was started to be collected across industries, it turns out that our averages for THC numbers were exactly what the averages have been for most of these accredited labs these days. So it turns out we were not low. We just were not boosting our numbers, which is one of the big um, issues I want to talk about in this talk. Cannabis Research was eventually sold to a company called Evio Labs, and I worked there for a short time, for a couple of years. I was the chief quality officer and then later the director of operations, managing around 4 or 5 labs that I all uh, helped onboard all of their quality systems and help them get accredited, help them with issues that they had around operations issues, method development, all sorts of things. And then I ended up leaving the compliance testing side of things in 2017 and switched over to the production side. Still working in testing though. I helped a company called Indomira build an in-house analytical lab and participated in their research and development team for a while with their science team that was led by Dr. Kevin Spellman, as well as a variety of clinicians, things that were part of that team at that time. And in that, I not only was doing a lot of cannabis in the form of hemp, but cannabis testing there, but also all sorts of other ethnobotanical products that we were evaluating, and was also heavily involved in guiding them through FDA compliance, good manufacturing practices compliance, and that sort of thing. And then more recently, I've been doing a lot of private scientific consulting around laboratory work, helping universities get labs set up, get methods developed, that sort of thing, and helping other private companies develop their in-house analytical labs. So this is something I've been doing for quite a while. In general, I love studying plants and studying the chemistry of plants and trying to understand how they work. And so in everything that I've been doing, that's been the main thread. And through all this time, I've seen a lot. I mentioned that with Kinovir research, we were operating before lab testing was even required. Um, my experience in the Oregon market has been, starting out when there's basically no infrastructure, no dispensaries, no testing requirements, and riding a sea of regulatory changes all the way to full legalization, robust testing requirements, and accreditation requirements, that sort of thing for labs. So I've seen things go from the wild, wild west to the highly regulated and everything in between. And I've learned a lot. So that's kind of my background in cannabis testing, just to provide some, uh, kind of insight there. So to start out, why do companies get products tested? Yeah, a lot of times we assume it's just regulatory compliance, but there's actually more to it than that. Um, Companies want to get products tested because obviously they want to be compliant with regulatory rules and stuff, but also um, when a company is developing a product, oftentimes they need a lot of tests in order to hone in on how they're going to produce that product and to meet certain quality requirements that they have for that product, whether it's, they want some product to be a certain THC potency or a certain CBD potency. And, let's say if you're manufacturing gummies or something and you need them to be 5 milligrams of THC per gummy, there's a lot of testing that you often need to do, from flower to extract to refined extract to finished product, while you're developing your procedures to make sure that you've got a really solid process in put together, so that if you follow those standard operating procedures every time, you'll get the same outcome every time. So there's a certain level of kind of process validation, quality management, product manufacturing, R&D that's associated with testing that falls outside of just the strict regulatory compliance testing. Some companies decide to go above and beyond with testing because they want to differentiate their brand from others. So they want to show just how clean their products are from harvest all the way to final product, or they want to test beyond what's required for regulatory compliance. Sometimes companies choose to test because they need to ensure that they have a very strong traceable record of the quality of materials throughout an entire product life cycle, just for legal defensibility. And if they're making claims about something like terpenes or cannabinoid potency or something on a product, they better be able to back those claims up with data. So there's a lot of different reasons why producers engage in testing. It's not just regulatory compliance. And so the data that these labs issue matters. It affects a lot of different things. It can affect not just, whether a company is legal or not, but it also affects whether, they can defend their claims, whether they can actually formulate the product that they're trying to formulate. And if they're getting bad data, then they can waste a lot of time and resources in, trying to achieve their goals. Testing matters. So what's the problem, and why am I even, kind of having this talk today? So there's a big data problem among cannabis testing labs, and it's primarily around potency testing, but not always. And so here are just a couple little snapshots of things that have been in the news and in public records, as of late. But it's obvious that um, products are getting test results that don't make sense. And primarily that THC numbers are all over the place and tend to be higher than they should be. And occasionally there are labs that are even passing samples for microbiological contaminants, pesticides, things like that, um, falsely when those products do actually contain those contaminants. And the problem, particularly with potency testing, is pretty significant. So here's one study from 2018 that showed that when you look at THC levels in different products across different labs, you can see that some labs have very strange, what's called distribution patterns in their results. And so if you look at these, let me see if I can turn my little thing on here. There we go. So, nope, it went away. Bear with me for just a second. There we go. All right. So you see these little figures here. These represent, basically the averages of the results that are being issued by this lab. And it's saying that in general, having total THC values for cannabis flower that's, below 10% is pretty rare. Most of it on average is, around the 17% mark for this particular lab. Then it kind of tapers off towards the top, and anything above like 28% or so is pretty rare for this lab. And you see a kind of nice, even distribution. But then you see this over here. And this is saying that this lab basically never reports anything below 16% or so. And the bulk of what they're reporting is above 20% and tapering off above like 26%. A huge discrepancy between this lab and this lab. And you see other things in between. Um, and generally, what you expect to find in this type of study is a nice kind of smooth, spread out, kind of looks like an eye, sideways eyeball, like an eye shape. Um, on here. You don't expect to see something like this, something like this. That usually indicates that there's some sort of bias in the reporting or in the data collection that's grouping numbers together, um, when there should be more of an even distribution. And we see stuff like that everywhere throughout here. And the quote that I have here kind of summarizes it, that these interlab differences in cannabinoid reporting um, persisted even after they controlled for confounding variables. So they tried to control for, the fact that there are different products and these labs are in different places and all these different things. But even then, we see that these labs do not agree. That labs, depending on where you go, will give you very different results. And that's a problem because that leads to lab shopping in the industry, where a producer will try to find the lab that's more likely to issue the type of results that they're trying to get. And typically in the industry, a lab like Lab F or Lab E are probably going to have more clients and be more successful than these other labs because they tend to report higher numbers more often than not. And the numbers, the like highest numbers that they report are higher on average than their competitors. Another example of this problem. Um, so here's another study that shows that there's an unusual spike at the 20% mark. So 20% THC, there's an unusual spike in average test results that are issued. Once again, normally you'd want to see a nice smooth distribution curve here, but that's not what we see. We see a bias here at the 20% mark. Why is that? Well, the reason is because many dispensaries pay higher dollar for flower that tests at or above 20% THC than things that don't. This leads to producers searching for labs that are likely to give them results that are higher than 20%. The labs start to realize that and they play to that. And that's where this incentive for fraud starts to come into play for the labs. Um, and so obviously there's something fishy here. There's definitely some fraudulent activity happening. This isn't a natural distribution of data. Um, so what I want to do in the rest of the talk is explain what labs do, how do labs assess their own accuracy and precision, and then in the end we'll talk about how labs boost their numbers. What are the different strategies they use to boost their numbers? Um, so let's move forward here. So what do labs do? A typical cannabis testing lab may offer a variety of services, typically depending on the state that you're in. They'll do things like foreign matter screening, microbiological testing for like bacteria, fungi, agrochemical testing for things like pesticides, plant growth regulators, metals testing, residual solvent testing, moisture content, and water activity, and I'll explain the difference between those. And then cannabinoid and maybe even terpene potency testing. And there's other stuff that labs do, like sex testing or sometimes even micropropagation, things like that. But we're not really going to get into those types of services today. So a quick review of what these things are. Foreign matter screening, that's putting things under a microscope, looking to see what's there that's not supposed to be there. Hair, dirt, that sort of thing. Typical in herbal testing that you'd see in the natural products industry broadly. Microbiological testing, whether using DNA testing to look and see if there are any certain living organisms in a sample, or as you see in this picture here, taking a sample and putting it on a petri dish and letting it grow, and then counting, all the different things that grow on the plate. There's different ways to do it. It's just basically looking at, is there any bacteria or fungus, that's not supposed to be here. Oftentimes labs, when they're doing microbiological testing, they're often doing kind of broad, non-specific testing. Like they're just looking at what's called total colony forming units per gram of yeast and mold. Or they'll look for the presence or absence of E. coli or salmonella, that sort of thing. Really pretty simple tests ultimately. Then pesticide screenings. So looking at commonly used pesticides that are often used on cannabis. This is not just, this includes both organic and non-certified organic pesticides, depending again on the state and what the regulations are, what's required. It's important to understand that even organic pesticides can be found on the plant, especially when they are applied on the flower. And so pesticides in general should never be applied to cannabis when the cannabis plant is in full flower. Metals testing. So the cannabis plant is known to be a pretty good bioremediator because it can pull metals out of the soil. Those metals then get distributed to all tissues in the plant. They get more concentrated in the roots, but they do get distributed everywhere and can end up in high concentrations in the leaves and the flowers. However, most of the time, any significant metals contamination in cannabis products usually comes in the form of vape pens from the hardware that the concentrate or the cannabis extract is in for the vape pen. Also, occasionally, seedlings of cannabis may draw a lot of metals out of contaminated media, like contaminated rock wool and that sort of thing. Sometimes you see high metals counts, but in general, metals is not a huge concern for cannabis flower. Doesn't mean it shouldn't be tested for that necessarily, but from my experience and experience of a lot of my colleagues, it doesn't seem to be a huge issue for flower, more of an issue for extracts and young plants. Residual solvent screening. So when producers are making extracts and refined extracts, that often involves the use of at least ethanol or isopropanol or methanol, sometimes things like hexane, butane, propane, pentane. A variety of different solvents may be used. And so, in general, most consumers want to know that those solvents are not in their final products. And so, labs will do residual solvent screenings to try to ensure that all of those solvents are at non detectable levels, or at least at very low levels. It depends on the solvent and how dangerous it is. Sometimes there may be small amounts of butane or ethanol in an extract, which isn't necessarily concerned, whereas you don't really want any benzene or hexane, pentane, that sort of stuff, or methanol in your extract. Moisture content. So this is just how much water is in the sample. Very simple. And I always tell folks that usually 10% or less moisture content will pass the classic snap test, where if you bend the stem, it breaks cleanly rather than bending. But most places that regulate moisture content have a requirement of around 15% or below to quote unquote pass. I see a lot of really good cured cannabis flower testing at around 12% moisture content. Now, water activity sounds like the same thing, right? But it's not. So water activity and moisture content are different in the sense that water activity is not the measure of how much water is in a sample. It's a measure of how likely that water is to move from the sample. And you can think of it basically as humidity. So how much water that's in that sample is likely to be able to leave the sample and thus be available to microorganisms or other things um, that could be potentially hazardous. So if microorganisms have access to water, they can grow and spread and produce potentially mycotoxins and other things. So water activity is often used as a predictor of how likely a product may spoil on the shelf or in storage. Usually for cannabis flower, water activity of around 0.65 or below, and it's measured in active water units, so AW. So 0.65 AW is usually considered acceptable for cannabis flower. Something of around 0.75 or 0.8 or below is usually considered acceptable for finished products like edibles and that sort of thing. And then we get to cannabinoid potency, which is one of the main things we're going to talk about today. So just how much THC is in the product, how much CBD, how much THCA, etc. Usually labs are testing for anywhere between 7 to 12 or 15 cannabinoids. At a minimum, they're testing for usually THCA, THC, CBDA, CBD, and then usually CBG, CBC, CBN, maybe CBGA. And then if you're lucky, also THCV, CBDV, and then different degradation products of a lot of those different cannabinoids. And what you'll see on test results will kind of depend on the technology used to test for cannabinoids. So there's kind of a quote unquote hot method called gas chromatography, and then there's sort of a cold method called liquid chromatography. Gas chromatography involves vaporizing a sample before it's analyzed, which basically is always going to convert your THCA, your CBDA, your acidic cannabinoids. It's going to convert them into their quote unquote neutral counterparts, so like THC and CBD, in a process called decarboxylation. Whereas liquid chromatography does not expose the sample to heat, so you're not going to see those kind of transformation products or degradation products. And it gives you a truer sense of what's there. And then you have terpene testing. Terpene tests, highly variable. I often tell people take your results with a grain of salt, because most cannabis testing labs are not validating their terpene methods. And a lot of times terpene results are reported in a really simplified way and ignore the fact that a lot of these molecules come in all sorts of forms called enantiomers. It's basically like you have your left hand and your right hand. They're exactly the same, but they don't, you can't stack them on top of each other. Like I've got a thumb here and a thumb here. They're not necessarily symmetrical in that way. And so molecules are the same way. You can basically have a left hand and a right hand of a molecule. They're the exact same molecular formula, same atoms, same arrangements, but just in a mirror of each other. And so this concept is called chirality. And um, a lot of times labs are not differentiating between what versions of terpenes they're actually measuring. Plus, they're not really validating their methods a lot of times. So terpene results can be all over the place. Not to mention that terpenes change really easily. They're really simple molecules, very similar to pesticides and a lot of solvents. They're very sensitive to light and heat. They volatilize really quickly. And so a cannabis product can get a terpene test, right after it's been harvested and cured and everything. But what a consumer actually gets from a jar in a dispensary that's possibly been sitting there for days, weeks, or even months, um, they can have a very different terpene profile, and those test results could be meaningless. So just something to keep in mind. I mentioned plant sexing is another thing that cannabis testing labs sometimes do. Basically look at the DNA of the plant and say, is this a male or female? Or is it unknown and, highly likely to be a hermaphrodite? We're not going to talk very much about that in this talk. So what makes any of these tests reliable or high quality? So the first thing I want to point out is that um, data can come in a couple of different forms. You can have qualitative data, which is kind of general information about a sample, approximate information, things that are hard to quantify. These are qualities of the sample, but not necessarily quantities of that quality. Quantitative measurements, quantitative data is hard numbers, hard data, precise measurements of something. So the example I give here, how much THC is in this sample? A sort of qualitative answer would be a lot, or more than 10%, or more than 20%. A quantitative answer would be this is 16% by dry weight. So this will become important as we talk about the applicability of these methods, particularly to cannabinoid testing. So when we talk about cannabinoid testing, potency testing, there's a variety of different methods you can use to do that testing. I have 3 of them laid out here: thin layer, gas, and liquid chromatography. Thin layer chromatography is great for qualitative testing. If you just need to know that there's a lot of THC in here, there's a lot of CBD in here, or this is kind of a 1-to-1 ratio probably, or, sort of something like that, or this is totally decarboxylated, or this is not decarboxylated at all. If you need those sorts of answers, thin layer can be a great technology. And I actually teach workshops about how to use thin layer chromatography for cannabis testing at home. And you can find those in the Curious About Cannabis Learning Center. I think it's available in um, I think the premium membership gives you access to that, or you can buy it as a standalone workshop. It's a lot cheaper if you do the membership, though. Um, then you get into gas chromatography and liquid chromatography, which give you pretty precise results, pretty hard numbers, which I will say thin layer chromatography can be quantitative. There are ways to make it quantitative. You can count the pixels that are in these dots that show up on these plates when you're doing thin layer chromatography and correlate those to concentrations of compounds and get pretty darn accurate results. However, it's not usually the best technology for quantitative data, but gas and liquid chromatography is. And so when we're talking about cannabis, I mentioned that gas chromatography is going to decarboxylate your sample, whereas liquid chromatography won't, ideally. And so then you get into another situation of what kind of quantitative data do you need to know? If you only need to know total THC, total CBD, which would be how much THC is going to be in this product when it's smoked, when it's decarboxylated, then gas chromatography can give you great quantitative results for total THC and total CBD. But if you need to know the actual amount of THC, delta 9 THC in a sample outside of total THC, separate from THCA, then you need liquid chromatography. And the total THC can be calculated using a certain mathematical formula when you know the results of THCA and THC. So the methods matter, and each method is appropriate in different applications. It's not that any one should always dominate. In my personal lab, I have thin layer gas and liquid chromatography available, um, depending on what I want to do. Sometimes thin layer is totally fine, depending on what type of research I'm doing or what sort of questions I'm asking. There are times where I just need to know total THC or total CBD on a sample, and I want to be able to do a run really, really quickly on my instrument. Gas chromatography is great for that. It can do runs, in as short as 5 minutes, and I'll have data and can move on. Liquid chromatography, usually the runs are a little longer. But if I need to know THCA for any reason or CBDA or something like that, liquid chromatography works well too, and is what I'm going to use for that. So you just always have to be thinking about what data do I need and what technology can provide me with that data, that sort of thing. Um, and then the reason why I want to bring this up is because, you know, you need to understand when a technology is appropriate to be used so that you can recognize when it's being inappropriately used. And there are labs out there that will use thin layer chromatography to issue test results on certificates of analysis that look just like every other certificate of analysis. Um, and they're really just estimating their cannabinoid potency. Or there are labs that are using gas chromatography to issue THC results, and maybe they're not actually communicating that they're reporting total THC and not actually Delta 9 THC by itself. There's all sorts of situations where that can be a problem. Also, understanding how these technologies interplay and what data they can provide can also help you suss out fraudulent certificates of analysis sometimes. When I was working at Cannabis Research, we actually had a situation where someone was making fraudulent COAs using our lab name, and they copied a lot of stuff, but they said that they were using gas chromatography, and then they had results for THCA and CBDA. And it's like, you can look at that and know, well, that's not right. How are you going to get THCA and CBDA values with gas chromatography? That being said, it is possible. There's a method called derivatization where you can get that information, but it's complicated, not very efficient, and no one does it in the cannabis space. So not really. So, um, it's just one example of how understanding these elements can help you detect fraud. And sometimes that's on the side of a producer that's making up test results. Um, so, how do labs know that their results are accurate? So, first of all, I want to talk about the difference between accuracy and precision. So, accuracy, when we look at this bullseye, accuracy is how on target you are. How close to the bullseye are you getting? Precision is how often can you hit the bullseye? And the goal of a lab is to produce data that's accurate and precise. So it's not just about accuracy, it's not just about precision, it's about both. You want to have results that are on target every time. And there are different ways to measure accuracy and precision in a lab separately and together. And that's important to understand because I'm going to highlight some of the different types of quality control samples that a lab may utilize to try to measure these things. So let's go forward here. Another thing that leads to the development of certain quality control samples that a lab will use to understand their accuracy is they need to be able to prove what's called their positive and negative predictive power. So positive predictive power is, okay, your result is positive. How do you know it's actually positive? If you see, let's say, you're doing pesticide testing and you come up with a hit, how do you know that that pesticide was actually there? And you do that by running duplicates, taking a sample and preparing it separately twice, and then running those samples and making sure they come out the same. There's all sorts of different ways to do that. But then on the flip side, if a sample comes out not having pesticides, how do you know that it didn't actually have a pesticide that you just didn't see? How do you know that your non-detected result is true, is accurate? And one way that labs will measure that is they'll actually take a sample that they're running, like a client sample, and they'll take a subsampling of that and spike pesticides on it so that they know that there's a certain concentration of pesticides on that sample. They'll run it, and see how well their system will detect that spiked sample, compare that to the non-spiked sample, and be able to determine whether their negative predictive power is strong or not. And then another concept I wanted to point out here is just uncertainty. Uncertainty is wrapped up in all of science. There's no data that comes out of a lab that doesn't have some amount of uncertainty built into it. That's just the world we live in. Nothing is perfect. You can test a sample a million times and you're going to get a lot of different results, but they're going to be grouped into a certain window of results. Yeah, everything kind of exists in a cloud of probabilities and possibilities, um, and everything within that cloud can be correct, accurate. Um, and so it's important not to get caught up on like what is the true number for the sample? What is the true THC number? Is it really 16.5%? Well, why did this lab say 17%? Why did this lab say 15%? It's like, well, the statistical variation there is pretty normal. That's not weird to see. If you take a sample to a lab and they test it a bunch of times to get slightly different results, like, that's pretty normal, especially for a natural product like cannabis, where there's a lot of heterogeneity in the plant. And even if you grind a big sample up and mix it really well, you're still going to see some natural variation. Plus, there's all sorts of other sources of variation. How the product's sampled, um, the level of uncertainty associated with the scale or balance that's being used to weigh the sample, the amount of variation that's associated naturally with whatever pipettes and other liquid volumetric devices are being used to measure out the solvents that are being used to extract materials from these samples. A lot of times, labs are doing dilutions of samples to um, get a sample diluted enough that it doesn't damage their instrument or something. So every time a dilution happens, you run into the same sorts of variations, and you stack all of that natural variation, natural uncertainty on top of each other, and it leads to a noticeable effect. Um, that's all normal. And in general, for an accredited lab, most labs should be calculating their uncertainty to some degree, have some sense of, okay, our results are going to be accurate with a plus or minus X percent variation, And in general, I would advocate that all certificates of analysis should feature that uncertainty on the result, that the result should say, this product is 10% THC plus or minus XYZ percent. Um, but we're not quite there yet. So here's a look at some of the types of quality control samples you may see a lab use just to get the feedback they need to understand how accurate and precise their methods are. Um, and they're specific to different things. So you have things specific to the sample, things that are specific to the batch of samples that they're working on at a time, things that are specific to the instrument that the samples are running on, and then other things that are specific to things like the refrigerator that a sample was stored in. And so just to briefly kind of highlight some of these, and I don't expect you to necessarily remember all the details here, but I just want to give you a picture of what a good lab should be doing to measure their own accuracy and precision. So on the sample side, for a specific sample, um, there's typically going to be duplicates being done for samples. It's not necessarily always expected that a lab's going to do duplicates of every sample, but for every batch of samples they're preparing, they should be doing a duplicate for every to represent every sample type. So if they're doing a batch of 10 flower samples that they're preparing to test, there should be at least one duplicate of a flower sample in there. And if there's like five, scraggler extract samples there, there should also be a duplicate of one of those extract samples. But ideally, and how we were doing things, in the early days, we were doing duplicates of every single sample. And that's one reason why I developed a lot of confidence in my own abilities, because I was doing duplicates and sometimes triplicates on every single sample and looking at that variation and trying to prove to myself that the data I was getting was reliable. I already mentioned the matrix spikes, so if you're expecting to not see something, and this is particularly the case for pesticide testing, residual solvent testing, basically contaminant testing, usually, because you don't actually expect to see those contaminants in most samples. So that's where you're going to see matrix spikes, where you're actually spiking a sample with a contaminant to make sure that if it were there, you would see it. And then again, you'd want to do matrix spike duplicates. So not just spike a sample once, but do that twice and make sure that there's not an error in your spiking technique that you're using. Then on the batch level for the whole batch, there's a thing called method blanks where you're basically preparing something that's similar to a sample, but that contains no analytes of interest. So typically this would be, for cannabis flower, a method blank would look like some other plant that doesn't have cannabinoids in it that's being prepared, or some labs will use like sand or tiny glass beads or something to kind of imitate preparing a sample. And the goal of this is to ensure that, in fact, that sample comes out clean. And if it doesn't, it shows that there's cross contamination in your lab, that your tools are contaminated, something's contaminated that's introducing analytes into a sample, which could then compromise the data for every other sample that's been prepared, in that time frame. Then there's laboratory control samples. These are samples of a material that have a known concentration of your analyte of interest. So an extract that has a known amount of THC in it that you know what it should come out to every single time. And it goes through the same preparatory steps as anything else. So it's how we would make this back in the day is, you would really finely powder some cannabis, and you would often then split that in half and decarboxylate half, then mix it all back together. And then you would run that sample 10, 20, 30 times and come up with a statistical average uh, for that material. And you would understand the variation and everything. So you knew what the THCA, THC, CBDA, CBD content should be for that sample within a reasonable range. You chart those results over time. So every time you run a laboratory control sample, you're adding to this chart. And if it's starting to deviate, if something's going wrong with that sample, you'll start to see the results, move down or up depending on what the situation is. And that tells you that either your laboratory control sample is compromised or something else is compromised. Basically, you need to stop and look at what's going on. And if it's just the laboratory control sample that's gone wrong, then you can make a new one, or do something like that. And then, of course, duplicates of the laboratory control sample are very useful. Again, these duplicates are primarily about precision. So are you going to get the same result if you did it again? Then the instrument specific stuff, solvent blanks, these are basically just squirting clean solvent into a vial, running it on an instrument, and making sure it comes out completely clean with no hits. If it does come out with hits, that tells you that your instrument is contaminated and that you need to not run any other samples until you fix the problem. And then these others are calibration verification samples. So these are samples that are basically known concentrations of an analyte of interest in a clean preparation. So pure THC reference standard at a certain concentration that you run every time so that you can understand whether your instrument is still calibrated or not. And usually the initial calibration verification is done with a different lot of reference standards than when you made your initial calibration, so that you know that if you got a different batch of reference standards and you ran them on that instrument, is the instrument still in calibration or not? And sometimes it goes as far as getting a different lot from a different vendor for those reference standards, just to really be sure that things are really well calibrated. And sometimes that tells you variance to expect between vendors of reference standards as well, which is interesting topic for another day. Other things that I've got here, field blanks. These would be blank samples, like taking a jar and basically keeping it open while you're sampling something and then closing it and then swabbing that jar later and testing it and just making sure there's not cross contamination during the sampling. Fridge blanks would be usually just solvent blanks that are sitting in a refrigerator or freezer somewhere where samples are being stored. That's tested routinely to make sure that there's not cross contamination within that refrigerator, etc. So here's kind of a breakdown. You'll find this chart in the Curious About Cannabis book. So if you're interested in all this stuff, definitely check out the book. You'll be able to dive into this a little more in a little more detail. But what I just want to get across to you is just how much a lab has to do to ensure their data is good. And right away, if you're trying to evaluate a lab, if they're not doing these things, um, that's a huge red flag. And labs, they put in a lot of work to do these things, and so when they're asked about them, um, they're often kind of like proud to share that information and to talk about it because it usually gets unrecognized. Um, so I just want you to be aware of some of these names of these samples and just to have a sense of what a lab has to do to understand its own accuracy. It's not as simple as just getting an instrument set up, getting trained on that instrument, and then putting samples in and getting data out. There's a ton that you have to do to ensure that that data is reliable. So before we talk about fraud and all of the different ways that cannabis testing can go wrong, I want to talk about the life cycle of a lab sample because all of this is going to come into play because there are ways to manipulate data at every point along this life cycle. So it starts with sampling. How do you get your sample? Either the customer is going to bring it to the lab in some cases, or the lab is going to send someone out to sample that material themselves. Then the material has to get to the lab where it goes through intake. And after intake, it should immediately then get preserved in some way. The sample's preserved until the sample's ready to be prepared. So sample preparation means that the sample's getting homogenized, it's getting put under solvent, so there's an extraction happening, and then that extraction is that material is then being filtered, diluted, and then it's ready for analysis. Then in analysis, the sample is being injected onto the machine, and data is being generated, and then finally with reporting, that data is being interpreted, put into some form that the customer can understand, and then that's delivered to the client. So these are the main, points along the life cycle, and we're going to highlight how lab data can get um, construed in different ways at each of these points, and even before these points, because we're going to talk about leadership and other things too that go into making a good lab. So, where does cannabis testing go wrong? The first place it goes wrong is leadership. So I recommend when people are critically evaluating labs, first thing you should look at is who owns the lab, and not just the lab location, but the company behind the lab. Who's actually running the show, um, and do they know what they're doing? Now, I've seen plenty of situations where that is not the case. People with finance backgrounds that are running huge lab companies that have no business working in this space, that don't understand anything related to what the lab's actually doing. That is a red flag to me. It's easy to get instruments to build a facility. If you have the money, you can have a lab built. It looks great. It'll look awesome. Everything's nice and clean and shiny, and people are wearing lab coats, and it fits your conception of what a lab is supposed to be. That does not mean that there's good work happening there. It's easy to cast that illusion. So, who owns the lab? Who's responsible for providing resources for the lab? And are these people, do they have a good reputation in the community? Who knows them? There's a lot of people out there chasing the green rush that think that lab testing is this gold mine to be tapped into. And, that's something people should be skeptical of. And then also looking at, um, whether there are other conflicts of interest between the owners of the lab. Do they own other companies that are involved in the cannabis space? Is there anything that they're involved in that could incentivize them to commit fraud in any way? And then from there, who's actually running the lab location itself? Who's the laboratory director? Who are the analysts? And what are their qualifications? How long have they been doing this? Do they actually have any academic training in biology or chemistry or anything like that? And then another thing that I encourage people to look at is, do the employees there seem happy? Do they seem like they're, relatively content with their jobs, or do they seem super stressed out, um, kind of manic, that sort of thing? That can tell you a lot about the company culture and can indicate some things like maybe this lab doesn't have the resources they need. Um, there's a whole thing in laboratory accreditation where technically the lab staff are supposed to be insulated from things that may pressure them to make mistakes or commit fraud and things like that. And when they're not properly insulated, they get super stressed out. And so those kinds of subtle cues can be strong indicators. Then from the leadership, you have the quality system itself that the lab is adhering to. So do you actually see signs that there is a quality system in place? Is there an employee who's actually a quality manager, that's the only thing that they do is ensure that the lab is adhering to their own quality standards? If not, that's a big red flag too. Quality management is a huge job. I know that well because I've done it in every single job that I've had. Um, it's something that requires all of your attention and energy. And if you're being spread out as a quality manager to also being an analyst, also being a lab director, also being an accounts manager, whatever, that's a red flag. Of course, we've talked about accreditation. Is the lab accredited? If so, to what standard? This is very, very important. So there are two standards that you really should know about in the United States if you're evaluating labs. One is ISO 17025. The other is TNI or NELAP. Now, ISO 17025 is the recognized international quality standard for analytical labs. Um, Something you have to be careful of is there's also a standard called ISO 9001. ISO 9001 is a very, very simple standard that just covers quality systems broadly. It's not specific to analytical labs at all. And that's the main thing I want you to know. ISO 9001, not specific to analytical labs. ISO 17025 is and is more stringent and really the only thing applicable here. So if a lab is touting ISO 9001, red flag. Why don't they have ISO 17025? Now, TNI or NELAP, NELAP stands for the, oh, do I remember this? National Environmental Lab Accreditation Program. And TNI stands for the NELAC Institute, if I remember that correctly. Yes. And all NELAP is ISO 17025 with some extra requirements on top specific for usually environmental labs. And sometimes cannabis testing labs get kind of wrapped up into environmental testing and that sort of thing, depending on the state. Like Oregon required NELAP accreditation and not ISO accreditation. But the way I explain it is NELAP is ISO, but it's a little harder to get. So if someone's NELAP, that's great. And if they're ISO, that's good. But one thing I want to point out too is an accredited lab is not necessarily a good lab. It's easy to get accredited the first time. And so especially if a lab is new, their accreditation should kind of be taken with a grain of salt. It's easy to get the lab set up. It's relatively easy to get it accredited when you don't have much data to for an accreditor, an accrediting body to look at. And it's easy to clean things up right before an inspection. And so accreditations are nice. They definitely tell you that there's a quality system that has at least been drafted and should be in place, but it doesn't necessarily, you've got to still look for all these other signs that, the quality systems are working and that the accreditations are meaningful. You're going to want to look and see, does the lab participate in proficiency testing where they accept samples from third parties, where they test it and they have no idea, what the data is supposed to be, and then they report it and they find out if they're right or not. You want to find out, how does the lab validate their methods? How do they qualify their technicians to do the work that they do? Another thing related to this is subcontracting. So some labs will do some work in-house and then they'll subcontract other work out to someone else. And that alone is normal and not necessarily a red flag, but you want to understand who those subcontracting labs are and what their credentials are. And the same sort of scrutiny you would apply to the lab you're evaluating, you want to apply that scrutiny to their subcontractors as well. So if they're subcontracting, not a big deal, but they better be transparent about it. Subcontracting labs should be featured on the certificates of analysis. They should not be hidden. And a lab should be very open about their subcontracting. And if they're not, that's a red flag. All right. So now getting into the life cycle of the sample, where can things go wrong? So sampling should be random, but it also needs to be representative. And random sampling doesn't always mean representative sampling. So what do I mean by that? So some states like Oregon, California, others will require that random sampling is performed, where labs will kind of grid out a container of cannabis and assign numbers to these grids and things. And they use a random number generator that then tells them where they're going to pick samples from, so that it's random. The problem is you can randomly get the same number 5 times in a row. So taking a sample from the same spot 5 times in a huge 10-pound bag of cannabis, is that representative? No, it is not. So you want to understand how a lab is sampling and how they're achieving both random and representative sampling. If they're just doing it randomly, that just doesn't necessarily mean it's going to be representative, and that can still lead to biased sampling. So there needs to be some other method involved to help steer it towards representativeness, like requiring that random samples are taken from every subunit that they've broken that batch into, or whatever, taking samples from every container regardless of what the random number generator tells you to do, that sort of thing. Tools need to be cleaned. One thing that a lot of people don't understand is that, for instance, if you're sampling an extract for residual solvents, you cannot clean your tools in the field. You cannot spray your sampling tool with isopropanol when you're sampling a product to be tested for solvents. So tools need to be pre-cleaned. There need to be lots of tools, and generally samplers ideally should not be cleaning tools between batches. They should just be getting new pre-cleaned tools out of their toolkit. So if a sampler is using one set of tongs or one scoopula or something and just cleaning it between each batch, that's a red flag. And that could lead to cross-contamination and all sorts of issues. Samples need to be preserved from the moment they're sampled. That means they need to go into a cooler and be cooling down, especially when we're talking about terpenes, solvents, pesticides, things that are very sensitive to heat, that can volatilize easily. They need to be preserved. And even with cannabinoids, if something's being sampled in the middle of summer, for instance, well, if that sample sits in a hot car while that sampler is going to do another job, it could start decarboxylating and other things like that. And then finally, samples need to be homogenized. There shouldn't be a cherry picking saying like, oh, we're going to test this bud because it looks the best, and we're going to take all of the stems out, and we're going to kind of trim it up too, so it's like perfect. No, whatever is collected, it needs to all be ground up. It needs to be well mixed, well homogenized, and then subsamples taken from that, bit of what eventually looks like dust. That needs to be subsampled, and it has to be tumbled and mixed. I mean, trichomes, they naturally sift. So if something's just ground, that's not enough. You've got to tumble it and everything, and then subsample, and tumble it and subsample. So you can see, like, there's a lot of ways for this sort of biasing to happen. If you don't do that tumbling thing I was talking about, then you've got trichomes that sift to the bottom, and then anything you sample from the bottom, it's going to be more potent than the things you sample from the top, for example. Another thing about cannabis is that it exhibits this phytochemical polymorphism. So the chemistry of the plant is different in the top of the plant, the middle of the plant, the bottom of the plant, the sides of the plant versus the insides. So that's another reason why you've got to sample. If you're sampling a plant, a living plant, you've got to take from all sorts of different parts and mix it all together. But even just outside of that, in dried cured cannabis, you've always got to take a lot of sample, grind it all up, mix it all together, because you are trying to overcome the natural heterogeneity of the plant itself so that you can get to some reliable data point. So now we're moving into preservation. So we've gotten the sample, we've gotten it to the lab. How's it being preserved? Um, you know, this really comes down to how does the lab ensure that its methods for preservation um, are adequate. So if they're using a cooler in the field and they're putting samples into a cooler, well, do they have a thermometer in that cooler that's being monitored and tracked? How do they know if something fails and all of a sudden it heats up? Is their digital thermometer going to catch that and provide that information to them? When it gets to the lab and it's in a fridge, how well tracked is that fridge? Is the temperature monitored, every day? Is it being, ideally, it should be digitally tracked. So hooked up to what's called a thermocouple, where the temperature of that device is being fed to a USB stick or something constantly. So if there's a temperature spike and what time, and you can see, oh, I opened the door and the temperature spiked, that sort of thing. But also this relates to trying to prevent cross contamination by ensuring things are well sealed. So what containers are being used? When cannabis samples are taken, they ought to be in samples that are protect them from light and heat and oxygen. And so usually for cannabis flower, that's going to be things like Mylar bags that are going to keep any light away, and that are can be sealed really, really well, that are going to contain everything. For things like extracts, you would expect them to be in like blue or amber jars that are going to protect them from light exposure, that can be really well sealed, with seals that are compatible with the material in there. So there shouldn't be um, seals made from materials that can easily be degraded from terpenes and that sort of thing. And then also when we're talking about preservation, this also relates to sanitation. So how well is the storage environment being cleaned and monitored so that you're sure that there's not going to be some sort of cross contamination, not some exposure to a contaminant, in the place where it's being preserved. Um, an opportunity for fraud that I want to point out here related to preservation. Once a sample has gotten into solution, meaning that it's been extracted and filtered and you're just left with a liquid, um, one way that labs may boost numbers is they'll take the cap off of that vial and just let it sit out for prolonged periods of time so that the solvent evaporates out and the THC in the sample gets more concentrated because the solvent is evaporating out. Um, it's one of these things that easily goes unnoticed and would not show up in an accreditation inspection or anything like that, but has a really big impact on final numbers. So now we're getting to sample preparation. So um, here's a whole list of series of questions that I would invite you to ask a lab about their sample preparation process. How do they homogenize samples? How do they ensure that the tools they're using for homogenization are clean? How do they monitor their samples for degradation throughout the process of sample preparation and storage? How do they know that each technician that their technique is good enough to prepare that sample in a way that's going to lead to accurate and precise data? Usually technicians have to be subject to demonstrations of capability, where they have to prepare samples multiple times and generate these kind of large data sets to show like, oh, their pipetting technique is good and they do get the same result for the sample every time, and that result is accurate. Usually that'll be done with a laboratory control sample, so they can evaluate that. Also, you want to understand, how does the lab calibrate their equipment that they use for measuring things, whether that's the weight of a sample or the volume of liquid. Another opportunity for fraud that comes up here is a lab can purposefully use tools that are not calibrated or calibrated inappropriately, so that, for instance, with a pipetter, a volumetric dispenser, you could calibrate it so that, let's say you think you're dispensing 100 microliters of solvent, you're actually dispensing 95 microliters of solvent, which will ultimately bias the result up. because you're not diluting the sample as much as you should. Same with a balance. Balance can be calibrated in such a way that you think you're measuring 100 milligrams of a sample and you're actually measuring 125 milligrams of a sample, which is going to boost those numbers up. So calibration of support equipment like that is a big opportunity for fraud. And this is basically what I just told you here. Um, so then we're getting into analysis, and this is where I think a lot of people expect the fraud to happen, but I don't actually think that's the case, because this is actually where um, accreditation inspectors and things focus a lot of their attention. And I've talked to a lot of these folks that do these audits, and they have a hard time finding evidence of fraud, even though they know it's happening. And so I don't think it's actually often happening at the analysis level. However, I'll still explain how it can go wrong. So, first of all, you want to understand, how does the lab calibrate their instruments? How do they verify that calibration and that sort of thing? How do they monitor for what's called carryover, where if they see that something has a hit for a pesticide, how do they know that that pesticide is not going to linger in the instrument and affect the next sample that comes after, and that sort of thing? And another good question to ask a lab is, do they perform what's called manual integrations, where this is where they manually adjust the raw data of the that's coming off the instrument. And I want to focus on that because that is one area where you can see some significant fraud. So manual integrations are normal. Sometimes when you're running samples, the instrument is programmed to recognize, what molecule is what on these graphs that come out, and how to measure them. And sometimes it just doesn't work out right for different reasons. Some samples just look a little different on the instrument than another sample that you think is similar. And so you have to go in and tweak things. The correct way to do this is to always maintain records of your original data and your post-adjusted data. So if there's a manual integration, there should be a link to what the original data was, and that manually integrated data should have a narrative on it that explains why it was integrated. And it can be very simple sometimes, but there needs to be some explanation, and then some traceable record back to the original data. If there's not, that's a huge red flag. And it's not something that customers would be privy to necessarily, but auditors look for that. And that's why I say I don't think this is where a lot of number boosting actually happens, but it could, especially in states that don't have strict accreditation requirements. So to explain this a little more, I want to show you what these graphs look like that come off these instruments. So uh, most of the time when we're talking about analytical data, we're usually talking about chromatograms. And this is what a chromatogram looks like. You have these little peaks and valleys, and the peak corresponds with some molecule that was detected, and the area within that peak correlates to some concentration. And when you're calibrating an instrument, you're basically telling it, like, how does the peak area correlate with a known concentration? And then that's how the instrument, starts to suss that out. So, you've got peaks, and then you have what's called the baseline at the bottom. And this baseline is actually full of noise. It's not actually a flat line. It's actually a very spiky line when you zoom into it. And another thing that labs have to figure out is what's called their limit of quantitation, which is how low can they measure something before they start getting into all of that noise. I'll save that for another time, because that's not going to be totally relevant for what we're talking about today, but it's worth knowing about. So chromatograms gone wrong. This first chromatogram here on the left shows you an example of what's called ghost peaks, where there was, let's say a solvent blank was injected on this instrument, but they're seeing peaks. That tells you that the instrument is contaminated, because they should not be seeing peaks. Likewise, if a sample, let's say these are pesticides, and a sample was run that had high detections of these pesticides, and then they run another sample after that sample, and they see the same pesticides, but actually those pesticides are not in the sample. Those are ghost peaks. Um, you also have what's called stacked or co-eluding peaks. This is when you have what's actually multiple molecules that show up on the instrument at such a close time that they look like one giant peak. And so labs have to have methods for looking into that to try to understand whether a peak they're looking at is really just one peak or is there actually multiple peaks stacked on top of each other. And there's all sorts of different ways that they can do that. They can analyze a sample, using several different technologies at once in the context of HPLC or liquid chromatography. You often use a UV light to, you shine this UV light at certain wavelengths to measure these compounds. And you can use it's called a PDA or DAD detector that will shine multiple wavelengths of light simultaneously. And then you can look at multiple chromatograms at once. And that will sometimes tell you whether you've got co-eluding peaks or not. That's very common in terpene testing and sometimes pesticide testing and things like that, where you can see that can go wrong. And so in general, you always want to see nice cleanly separated peaks. You don't ever want to see peaks that are kind of overlapping or that have shoulders here. So you can see here these are likely two different peaks that are just too close together. And then another thing you should never see are what are called shark fins, where you have what looks like a shark fin on the peak. This tells you that the molecule is being detected fine as it interacts with the instrument, but it's not pulling away from the instrument cleanly, and it's leading to probably an exaggerated result, and that sort of thing. So I just want to show this to you, just some things you can actually see on chromatograms that can kind of be red flags if you do request chromatograms. And I do encourage people to request the chromatograms from labs because it's your data. You should be able to see it. And if you see a lot of this type of stuff, that's a red flag that something is not right with this method that they're using, or that they haven't properly validated their methods. A little explanation about calibrations. So I mentioned that you may want to ask a lab how they calibrate. So when a lab calibrates an instrument, they form what's called a calibration curve, where basically they run a sample at various dilutions, and then those results are plotted on a line, and then the linearity of that line is measured, and that tells you, how reliable your data is going to be if your data falls within any of those points. And that measure of linearity is referred to as what's called an R-squared value. And here are two examples of a calibration curve you could see with very different R-squared values. The first one is a lab that only did 3 different dilutions. So they took a sample and they, let's say it's 100 milligrams and 50 milligrams and a 10 milligram preparation, just to pick random numbers off the top of my head. Their linearity is not great. It's a 0.9. It's not as terrible as it could be. But by seeing the calibration curve and seeing, kind of where these points fall on this line, it kind of tells you that unless a sample is coming through with an amount that is falling really neatly in the middle of the calibration curve, the data may be skewed. And if it comes up higher on the calibration curve, the data is going to be skewed higher. It's going to be biased higher, a higher result. And likewise, by looking at this calibration curve, it tells you that if a result is coming out towards the lower part of their calibration curve, that data is going to be skewed low. And how a lab should deal with this, if they're just intent on sticking with this calibration curve, is if their sample that they inject on the instrument shows a value that is, too far north or south, they would then need to properly dilute or concentrate their sample to get it closer to the middle of the calibration curve. And that's not a situation you want to be in with an analytical lab. You want to be able to know that if you prep a sample all sorts of different ways, it should fall neatly in your calibration curve somewhere where you can trust the data. So that brings us to the next calibration curve here, where we've got 7 calibration points on this curve as opposed to 3. So we could say it's a whole series of dilutions covering all these different points. They line up really neatly. We have a 0.99999 R squared value, which is about as linear as it can get, which tells you that if this lab prepares a sample and the result comes out low on their calibration curve or high on their calibration curve, it doesn't matter. The results are still going to be reliable because the instrument is very well calibrated for all of these points up and down the calibration curve, and it couldn't get much better than this. So if you're ever in the position to see a lab's calibration curve for their instrument, just think about how these 2 examples look and just know that what you want to see is something with a lot of calibration points and an R squared value that's as close to 1 as possible. You don't have to understand anything else. Just know that. Just know that you want a calibration curve with as many points as possible, with an R squared value as close to 1 as possible. And now I want to talk about moisture content. So moisture content is very important when we're talking about potency testing because the amount of moisture in a sample will affect the concentration of other compounds in that sample. So labs generally want to report data as by dry weight, meaning that the sample has been, if it had no water in it, this is what the result would be. And then from there, you can kind of, if you understand the moisture content of a sample, you can kind of correct that value to understand the actual concentration at any given time for a sample. Whereas if you just have the wet weight value for a sample, that's really just a snapshot of that sample at that one period of time at that one level of moisture. I hope that makes sense. What I want to show you is that when a lab is calculating the moisture content of a sample, it's easy to measure the moisture content too high. So if you try to dry a cannabis sample, you'll end up with a graph that looks like this, where there's a pretty sharp decline and then it kind of levels off a bit. Then there's a little bit more decline and then it levels off again. And generally with moisture content methods, what you're trying to do is dry a sample until the mass stops dropping, because the weight's going to go down and down and down as the water's leaving the sample. And you want to get that thing dry to the point that there's no more water coming off. The problem is that cannabis is full of volatile compounds that are not water that will also leave the sample. I'm talking about terpenes. I'm talking about volatile aldehydes and other things. I'm talking about carbon dioxide associated with decarboxylation of cannabinoids. So if you dry cannabis, you'll hit an initial equilibrium. And then if you let it cook too long or at too high of a temperature, you're going to see another drop where all those volatiles are coming off. And then you'll see another equilibrium. And so it's easy to overestimate the moisture content of a cannabis sample. And if you overestimate the moisture content of a cannabis sample, and then you calculate the dry weight result of that sample, you're going to get a higher number than you should because you're assuming that there's more moisture in there than there actually is. And there's a great chart in the Curious About Cannabis book that explains that and puts it, graphically in a much easier way to understand that I recommend you check out. But it's important because labs correct their results by dry weight. And so if the moisture content is wrong, then numbers are going to be boosted because of that. If you don't actually have a 14% moisture content, really you've got a 10%, but you've just you've decarboxylated the sample and purged all the terpenes off and lost all the weight from that. That's making it seem like your moisture content's higher, which is ultimately going to make your THC values seem higher when the final results are corrected for that. So then talking about analysis. So what are all the different ways that labs can boost their numbers? Just to review what we've talked about, we've got the sampling bias, cherry picking samples, not homogenizing, having miscalibrated balances and volumetric equipment. One thing I didn't mention is that some labs will standardize their sample mass to justify recording a lower mass than they've actually measured. So they may say that, okay, as long as it's below 0.245, we're going to round down to 0.2, or something. And so they'll measure 0.244, but just write down 0.2. And so they're actually measuring more than, they should. That's not so common in highly regulated, accredited labs, but it can happen. Moisture content overestimation, manipulating chromatograms with manual integrations that they shouldn't be doing. Their calibration tables can be manipulated to bias results. So like I mentioned, in this first example of the calibration curve, a lab with a calibration curve like this is always going to want to have their results, the concentrations of an analyte that's on their instrument. They want it to be in the upper part of the calibration curve because they know that the results are going to be biased higher. So even the calibration curve, can be used to manipulate results. And then there's just bad technique, improper dilutions, letting solvent evaporate out of samples. And a lot of this is stuff that can happen under camera and still be undetectable. If a balance is miscalibrated, a volumetric dispenser is miscalibrated, if sample masses are standardized inappropriately, calibration curves are being used inappropriately, that's all stuff that can happen under camera while people are watching, and they can get away with it. And all of that adds together to lead to dramatic boosts in THC values and terpene numbers and other things. And then finally, when we get to reporting, there is COA fraud, certificate of analysis fraud, where people just make up certificates of analysis. There's something called dry labbing, which is where a lab, is a lab by name, but really they just create certificates of analysis and don't actually test anything ever. Other things you should be watchful for on a C of A is, when a lab gets accredited, they have a scope of accreditation. And so certain tests that they do may be accredited and others may not be. And they're required to tell you which tests are accredited, which analytes are accredited, and which ones aren't. And if they're not telling you those things, that's a big red flag. You should also be looking at the subcontracting stuff. If they subcontract tests, that should be listed on the C of A. If it's not, huge red flag. The methods that they're using to test products should be clearly identifiable, and you should be able to understand whether the test method fits the results. Going back to that example I gave of the GC results that were somehow reporting THCA and CBDA, that's nonsense. You also want to look at who signed the C of A, who's actually putting their reputation on the line to say that that data is accurate, and what credentials do they have. Finally, if there are any calculations being performed, how are they being performed, and is it accurate? And that gets a little beyond what I want to cover in this talk, but in the Curious About Cannabis book, you can learn about how total THC, total CBD, et cetera, are calculated, and scientifically, where does that come from? And then you can learn how to evaluate certificates of analysis to make sure that those values are being properly calculated. So this is just kind of an overview of how things can go wrong. And then finally, I have a couple of just kind of tips on reading C of A's and interpreting data. Like I mentioned before, when you're looking at potency data, you want to know, are these results by dry weight or is it wet weight? If it's dry weight, then you also want to know what was the moisture content of the sample and how was that used to get to the final result. What method was used? Was it HPLC or GC? How is total THC being calculated? If you're looking at microbiological data on a C of A, you want to look for certain things. Like sometimes C of A's will list a whole bunch of microorganisms, but they will have only tested for certain ones that you paid for. And so, you need to understand the difference between seeing an ND versus an NT on a certificate of analysis. ND means none detected or not detected, which means they did test for that thing, but they didn't find any, versus an NT, which usually means not tested, which means they didn't look for it at all. So it could be there and you don't know. Very important to understand the difference there. If things were detected, what were the concentrations? In general, you don't want to just see like, yes, we detected it or no, we didn't. You want to know how many colony forming units per gram are there. Um, or in the case of DNA testing using a technology called PCR, polymerase chain reaction, you want to know. So PCR provides data in, it doesn't provide data in colony forming units per gram because you're not growing colonies of organisms and counting them. You're amplifying the DNA that's in a sample and seeing what's there. And so if they're reporting things in CFUs per gram and they're using PCR, you want to understand how they're converting their quantitation cycle data into CFUs per gram. Once again, another lecture for another day in the details of that, but something to be aware of. For pesticides, solvents, metals, these are usually reported in parts per million or parts per billion. And usually you hope to not see any detections. And so the main thing you're looking at here is, do we have any detections? If so, are they at or above regulatory, what are called action levels, which is kind of like the maximum accepted amount that contaminant could be in the product before it's deemed, uh, you know, um, not compliant with regulations. Um, and just because something is below regulatory action levels, you also need to understand how comfortable are you ingesting a contaminant at any level, and how, what's your comfortability with that. Some people don't want to see any contaminants. Some are willing to accept small trace amounts of contaminants. And so sometimes that's a personal decision on what you're comfortable with. Now, if you do see a detection for contaminant, you also want to look at that lab's limit of quantitation for that method, which means what is the smallest amount that they could possibly detect in that sample before they start getting into, the noise of the instrument and stuff like that. And a lot of times labs for these contaminants will set their LOQs at the regulatory action levels. And so if you see something that says below LOQ, you really need to understand what that means. Does that mean that there's actually none detected, or does it mean that there was some detected, but it's below the action levels and below, the LOQ that's established there? One thing I want to just iterate is below LOQ does not mean that there is none present in the sample. And so understanding what that LOQ is important in terms of determining your own tolerance for potential contamination in a product. And if you see hits of the same pesticides for multiple samples, you need to start asking questions about how the lab determined that there was not carryover from one sample to the next for that, because it's possible they may have actually just seen ghost peaks in samples that came after the first one that got the hits. And maybe some of the samples don't actually have detectable levels of pesticides in them at all. It's important to understand. So this is kind of a lot. I know I've thrown a lot out at you, but you may be asking, where do I start? And these are some recommendations I have, things to ask a lab to kind of begin your, critical evaluation of them. Ask them if they're accredited, who accredited them, and what is their scope of accreditation. That scope is so important. It's not enough to just say, yeah, we're an accredited lab. Well, what are you accredited for? Is it just moisture content, or what is it? Ask them if they outsource any analyses. Do they deal with subcontractors? And if so, who are those subcontracting labs and what are their credentials? What are the credentials of the lab staff and the owners and who's running things? What systems are they using for managing their data? How do they validate methods? How does their quality system work? Who's managing that quality system? How are samples stored? What are typical turnaround times? Are those turnaround times going to vary depending on the time of year? Generally, there's seasonality to cannabis testing, and turnaround times can get longer in around typical harvest times and stuff, versus kind of the off seasons. And of course, one of the big questions: how do you assure the validity of results if I'm not happy with the result? How are you going to respond if I'm concerned about a test result? And usually, labs are happy to retest things at no cost, to show that they have confidence in their results. And at a minimum, they're usually happy to sit down with you and talk through the data and try to understand where there might be some miscommunication, misunderstanding, or anything like that. And if a lab is just totally unwilling to meet with you, that's a red flag. So if you do run into problems with the lab, first of all, don't panic. Issues come up, and that's normal. The first thing you want to try to do is meet with the lab and try to talk through the results. What you don't want to do is immediately run to another lab, because that can confound the problem. Because if you don't understand the source of the problem, then sending samples to multiple labs and trying to collect data, it just adds more variables that you've got to sort through, and you don't know. It just confounds things. You really want to start with working with the lab that you got your first test result from and trying to work with them, have them retest the sample and see if the results come out the same. Try to make sure that there's nothing on your end as a producer that could have led to this result you didn't expect. And it should just be a good, honest conversation. You should also request to see all of the quality control data associated with your sample. Sometimes you'll get charged for this because it does take a lot of time and energy to collect all of the quality control data that's associated with the sample. Sometimes it means that you've got to redact information because there'll be information about other people's samples, in that data. So it's not uncommon for labs to charge a small, kind of filing fee, to collect that for you. But it's worth it to have if that data could mean, potentially millions of dollars or something of liability. You want to get your quality control packets, and not just the simplified QC data they may give you on your results. Like, there's a wealth of data that should be behind, your certificate of analysis that they can pull, pages and pages and pages of data. Um, so, know that you can ask for that. And like I said, if you find that a lab is resistant to any of these things, that's a red flag. Here are a couple of causes of kind of common causes of unexpected potency numbers, things that I've run into over time that sometimes producers don't think about, especially in R&D testing. And so if potency is often coming out lower than expected, it's often because there's too much leaf and stem on the buds. They just haven't been trimmed very tightly. There's a lot of heavy stems that have been left on, and that all reduces the total concentration of THC. So make sure your stuff is trimmed really well before you get the lab out to sample. If there's excess moisture, that's going to affect your results potentially, depending on how it's being tested. You want to make sure things are dried and cured really well before you send things to the lab, or before you have the lab come out. And don't try to get things tested too early. If you're too eager to get test results so that you can get things to market ASAP, you may be sacrificing, um, THC, CBD, whatever you're after. And you can use simple techniques like thin layer chromatography, or there's also other devices out there that you can invest in to do testing yourself to see when the THC has plateaued in your crop before you harvest. So just watch out for premature harvest. In like extracts, like distillates and things, um, sometimes these extracts, and I put distillates on here because I see most of this happen with distillates more so than anything else. But you'll get weird numbers because basically there's been a lot of degradation. They've been exposed to heat and light and oxygen, or maybe the distillation process is not well refined, not well validated, and you're actually turning these chemicals into other chemicals. You're degrading things into other things. And so you may expect a 80-90% THC result, and you only get a 30% because there's 30% something else and 20% something else and 10% something else that these byproducts that you've made. And related to that, I have these isomeric and analog byproducts from processing. Um, Similar issue, and I put this in here mainly related to when processors are trying to synthesize a different cannabinoid from their distillate, like they've got CBD distillate and they want to turn it to Delta 8 THC distillate or something. Again, you got to make sure your reactions are efficient, that your um, that your catalysts that you're using and everything are appropriate. There's a lot of good published scientific research out there that can help guide you in what solvents and catalysts that you should be using for those types of synthesis reactions. And then with edibles, one common thing that I've found is a lot of times when people are new to producing edibles, they are making them by measuring everything in volume rather than mass, and which is common in cooking, but will not work when you're trying to produce edibles that are consistent THC dosage or CBD dosage or whatever, um, for every unit. You've got to measure things in mass. It means you have to weigh all of your ingredients, particularly your whatever ingredient is introducing the cannabinoids, so that your all of your measurements will be very accurate and precise, and you won't get as much variation. When you're measuring things by volume, uh, density is not your friend. I mean, if the room is warm or cold, density of liquids changes, and you can end up getting very, very different doses of edibles that way. One thing that I commonly see is that producers are not testing their feedstock. So they're not testing the flower or the extract before they make their final product. So they don't know what they should even be expecting. They're just kind of making assumptions based on how their process is going, and not doing those spot checks beforehand. I already mentioned density, but ensuring that you understand how data is converted when you're dealing with liquids versus solids. So when a lab is issuing a result in percent, say something's 10%, well, that's 100 milligrams per gram. But if you're dealing with a liquid and something that is measured as a liquid when it's given to a consumer, well, you need to convert that to milligrams per milliliter so that you can actually understand dosing properly. And then finally, sometimes edibles and topicals, for that matter, will use ingredients like essential oils and things that have compounds that will coalute with terpenes and cannabinoids and things, and will cause really weird issues for the analysis, and the data will come out wrong. And in that situation, what you want to do is work with a lab, and you want to send them blanks of your product, basically your product that's made without the essential oils, without the cannabis, and then send them a sample with just everything's the same, but it doesn't have the cannabis, and then a product that has everything. And then the lab can start to see what is possibly causing any coalition problems or confounding the data. And this is all stuff I consult with. If you ever run into these problems, feel free to reach out to me. And this is something I help businesses with all the time, how to make sense of unexpected results. So the big question, is lab XYZ fraudulent, or is it something wrong with your process? What are these primary red flags that we've talked about with labs, so that you can find yourself a good lab and at least rule out that variable, so that you can trust your data and focus on what you do and make sure that you're doing it as best as you can. The big red flags that I tell people to focus on: uncredentialed owners and workers, a lack of customer service. If there's no way to get through to somebody to discuss your data, that is a huge red flag. If a lab kind of is aggressively defensive when you press them on a problem, that's a huge red flag. If you ask them how they measure accuracy and precision and they can't answer, that's a huge red flag. If the lab appears disorganized and chaotic and there's no clear signs of quality management in place, if you don't see binders of SOPs and forms and things, and logs everywhere that are tracking the temperatures of all sorts of different things, all that kind of stuff, that's a red flag. Also, ask around the community. If there's a lab that's known for high THC results and they're issuing results for flower that's, really, I say anything above 30%, but especially things I've seen results for 35 to 45% THC in a flower sample, that's bogus. And that's a red flag. If they're known in the community for being more likely to pass for contaminants, obviously that's a red flag. Um, if the certificate of analysis is bare and doesn't have information about what methods they're using or any information about quality control data or anything to help you interpret data, that's a red flag. And finally, if they're not accredited, that can be a red flag. But like I mentioned, just because a lab's accredited doesn't mean it's good. And the flip side of that is true too. Just because a lab is not accredited doesn't mean they're not good. Um, you really have to take everything into context. But of course, accreditation is something that in general you want to see because it helps you know that at least there's a third party that is coming in to audit this lab at least once every 2 years or so. And they are at least required to have some semblance of a quality management system if they're accredited, but it's not always going to do you right. So that's basically what I've got for you. So if you want to learn more about any of this, you can feel free to reach out to me directly. Um, and if you want to dive more into cannabis science and learn about, more about any of these topics, check out the Curious About Cannabis podcast, check out the Curious About Cannabis book, and you can find all of our stuff at cacpodcast.com. And you can reach me directly at jason@naturaledu.com. So hope you enjoyed this talk. Hope it was valuable. And I look forward to seeing what questions you all have. So thanks so much and stay curious and take it easy. Bye-bye.